Hello, and welcome to Radical Equations 2, the messy ones. This lesson is going to focus on some of the more complex and complicated radical equations that you might see. As always, give this video a like if you find it helpful. Super easy to hit that thumbs up button. Subscribe to the channel for more math content. And normally, I would say at this point, check out the practice set for this lesson. However, the practice is embedded in the lesson video this time. And that is because, as you will see, these problems do get very long and involved, and there's not like a great way to do a practice set of, say, 10 problems with this. So without further ado, we're going to talk about a couple of things with regard to more complex radical equations. And the truth is that you will not see many of these when I am teaching in my own classes. I often will not go this far with the difficulty level simply because it's just not a skill that turns up. However, you could see it in an advanced algebra 2 class as well as a college algebra class. So it is a topic that is worth covering. We want to talk a little bit about an extraneous solution and how it is handled. So the first thing about the equations in this lesson is that we open up the possibility of having what are called extraneous solutions. Inside that word, you might see the word extra, and extra you might think of as more than we need. And so an extraneous solution is a solution that results from correct algebra work, but does not work when checked. So you can do every step of your algebra correctly, and when you get to the end of the problem, you could have x equals some number, but when you plug that number back in, it doesn't actually work. And so this might seem like a serious problem and might raise this question: why do they occur? So what is it about these problems that causes these extra solutions to turn up? Well, in this case, they occur because of a nuance in definition in which when we take a square root, we only take the positive root as an answer. So here's an example. For example, the equation x squared equals 16 has two solutions, 4 and -4. And just so we can refresh that, if we have x squared equals 16, if I plug in 4, well, 4 times 4 is 16, and so that works. But -4 also works because -4 times -4 would also give us positive 16. But the equation x is equal to the square root of 16, that only has one solution, just the x is equal to 4. And that's because when we're taking that square root, we are only taking the positive, unless otherwise indicated. So it only has one. Now, if you were doing the algebra out for this, so if you had x squared equals 16 and you were going to show what you were doing, you would actually need to manually place out in front the plus minus in order to indicate that we don't just want the positive root, we want the negative root also. Now, when we square the equations in the process of solving, so if you watched the first video, Radical Equations 1, you know that when you're solving, like, say, a square root equation, you have to square both sides of the equation. Well, when we do that, when we square both sides, what we do is we take something that is in this form with just an x, and we square both sides, and we land here. And what that does is it potentially generates an extra solution in the work. So I'll kind of show you what we mean by that. Let me just clear this up and change colors. So if you had, say, that equation right there, and then you said, well, I'm going to square both sides. Now, according to our rules of algebra, as long as you do the same thing to both sides, you should be okay. So if I have x is equal to the square root of 16, then I should be able to square the left and square the right. However, when I do that, now I end up with x squared is equal to 16, and I have inadvertently generated an extra solution. So where that first one only had x equals 4, now when I square both sides, I have incorporated this -4 as being a possible solution. And so what we did there is we generate this potential extra solution that we might have. And that's what happens in the process of doing that correct algebra work, is when you get to that step where you square both sides, you introduce the possibility that you might have an extra solution. So last question, what do we do about them? Well, we have to check our answers. This can be done algebraically or graphically. I will kind of take you through both in this lesson so you can see what it looks like. But up until this point in our algebra journey, checking the answers has been something that we can do, but not necessarily something we have to do. Once we get to these kinds of equations, we actually do need to double check our work and see if the answers generated, because simply doing all the correct algebra steps is no longer enough to ensure that the numbers we're getting at the end are answers or solutions. So we're going to take a look at example 1. And what we can see here is I have the square root of x plus 4 is equal to x minus 2. And what makes this tricky here is that you have an x inside the square root and also an x outside the square root. And so we have to make sure, it's not, I guess, like if you watch the last video, it's not just a matter of like trying to undo the stuff that's being done to the x, because we have more than one thing being done. But the first thing I do notice is that I am square rooting. So what we are going to do is we are going to square this to get rid of the square root. When I do that, I have to square the other side, and I have to square the entire side, not just the x squared and the 2 squared separately. Can't do them cannot do them separately. You have to square the entire side as a group, just like we squared the entire left side. Now, when we square a square root, we will get what's inside. So this is old material. Now, right here is where a lot of students will make a mistake, and they'll say, oh, well, that's equal to x squared minus 4. No, it is not. It is x minus 2 times x minus 2. We have to square the whole thing, and that is going to be a multiplication problem. So you can use an area model like I am setting up. You can FOIL it, or you can do it in your head. If you've done enough of these, you can probably do them in your head. And so this will be x squared minus 4x plus 4. And so I get x plus 4 is equal to x squared minus 4x plus 4. And now I have a quadratic equation. And now you kind of go back to everything you know about quadratic equations and solve it from here. So we've got several strategies for solving a quadratic equation. One of which is to, well, we'll just go with either factoring with a quadratic formula, but for both of those, you need to get a 0 on one side. So I'm going to go ahead and subtract x and subtract 4. So this on the left will give me 0. And over here, I'm left with minus 5x, and then 4 minus 4 is 0. This I can factor. I see I have a common factor of x, so I'm going to factor that out. And then if I have two factors multiplied to 0, that means either the first factor is 0 or the second factor is 0. And here we will add 5. And I get x is equal to 5. Now, of course, I am assuming in doing that work that you are familiar with those strategies for solving quadratics, factoring, quadratic formula, all of that. If you find that you do need a refresher on that, please check out our playlists on quadratics, and you can find all kinds of factoring and all the things in there. Now, notice that my algebra here is sound, and I've got two potential answers. The problem is that not both of those answers actually check. So this is what a algebraic check looks like. So I'm going to take my equation, and remember that the solution to equation is the value of the variables that make the equation true. And so I'm going to plug in the 0. 0 plus 4 is 4, 0 minus 2 is negative 2, and the square root of 4 is 2. And we will notice that that does not check. And again, the little hiccup there is that when I take the square root of 4, I assume the positive. It goes back to what we had on the last slide there. And that lands us at an untrue statement. So x is equal to 4 actually does not check. If I try the 5, 5 plus 4 is 9, and 5 minus 2 is 3, and that one does give me the true statement, and so that one does check. So that's what the algebraic check looks like. You arrive at your answers and go and plug them in to see if they work. And here's what the graphical check looks like. So remember, the original equation was the square root of x plus 4 equals x minus 2. And what I did was I used a strategy where I set each side as its own equation. And then we're, of course, looking to see where they are equal, which will be where they intersect. And that is happening right there. And if I look to see where that point is, you will see that point is at x equals 5. Now, what's interesting about this is, and we haven't really talked about in at least this lesson sequence. I've taught this in different orders, so it's possible that you can do this out of this order, but what the graph of a square root function looks like, and what it is the top half of a sideways parabola. So if you were to take a parabola and then turn it on its side and then only take the top part of it, okay, that's what we're looking at. But imagine for a moment that the bottom part was there. If the bottom part of the parabola was there, okay, first of all, it would no longer be a function, okay, because the function would not pass the vertical line test. But look at where that point of intersection would occur. It would occur at 0, -2 is where it would occur. And so 0 would be the other answer if the bottom of the function was there, but it's not, because we only we assume the positive answer. And so x is equal to 5 is the only point of intersection. That is the only solution. Okay, so this one I actually did a couple of different ways because I was having issues. But well, let's go ahead and deal with this one. Now, this one, we have the problem of we can't actually isolate the radicals. So I could put both radicals on the same side and then try to square it. That is going to be an absolute nightmare. Okay, so what we want to do in this is want to isolate one of the radicals. In this case, the 2x, square root of 2x plus 3 is isolated, but you could add 1 to both sides and isolate the other one. I don't see any need to do that. And the way this is going to work is we're going to undo one radical, but the other radical is going to still be there. Now, I've done a lot of these in my life, and so I can do this in my head without a lot of work, but I'm not going to try to do that for you guys. So here on the left, if I square a square root, I get whatever's inside. So that side is the nice side. On this side, though, I am going to have to square that binomial. And for me, it often helps for me to write it out. I don't always do it, but I think it's worth doing. And then what we need to do is we need to, we'll say, FOIL that together. You could use the area model for it. That would be fine, but I don't think I have the space on the screen to do it. So let's see what this is. So we have 2x plus 3, and then what I'm going to do is multiply the square root of x plus 7 times the square root of x plus 7. So that would be squaring it. So I'm going to get what's inside. That would be, yeah, square root times itself. So I'm going to have x plus 7. Then I will have the square root of x plus 7 times -1, which is going to give us -1 square root of x plus 7. And then we'll multiply that negative through, which is going to give me another -1 square root x plus 7. And then last but not least, -1 times -1 is going to give me a +1. And so essentially that was squaring a binomial that has a square root in it. So much fun. Now we need to simplify this at least a bit. So I'm going to leave that left alone. I've got x, I've got 7 plus 1, which is going to give me 8. And then I can combine these as like terms. So I actually have -2 of them. And the thems is the square root of x plus 7. Now I can take these two terms right here and move them over to the left and isolate the new radical. So I am going to subtract x from both sides and 8 from both sides. 2x minus x is x, and 3 minus 8 is -5. Now, you might see, and I do not recommend that you write this down, to isolate the radical, that step. I actually don't like that step. I do not encourage you to do it. Then you end up like squaring something that's got like a gigantic fraction in it. What I've always recommended to my students is if you have another constant out there, keep that, just keep it there and square it when you square both sides. So now we've got to do the second squaring step. So we have to square and square again in order to get rid of the other square root. This will be x minus 5 times x minus 5. And this is what I mean when I say, like, just kind of leave it there. Okay, so when I square, so if you need to see what I did there, okay, I essentially did this: -2 square root x plus 7 times -2 square root x plus 7. -2 times -2 is going to give me the +4, and then the square root times itself is going to give me what's inside. Okay, so pause the video and you can just kind of inspect that scratch work. Over here on the left, I am just going to go ahead and multiply it through. So I have x squared minus 5x minus 5x plus 25 is equal to 4 times x plus 7. So this will be x squared minus 10x plus 25 is equal to 4x plus 28. Are you having fun yet? And finally, we've got rid of all the square roots in this, and I have just a garden variety quadratic there. So I'm going to go ahead and subtract the 4x from both sides and also subtract the 28 so we can get a 0 on one side. That is going to leave me with x squared minus 14x minus 3 is equal to 0. And then I know this, everybody's just gonna love this so much, that this is the quadratic formula problem here. So absolutely thrilled. So if you need a refresher on what the quadratic formula is, it is the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. So we will have the opposite of b. B is -14, so that'll be +14 plus or minus the square root of -14 all squared minus 4 times 1 times -3 all over 2 times 1. So this will be 14 squared, which is 196, plus 12 all over 2. And that is the square root of 208 over 2. Now, that is a bit messy, so I had to do quite a bit of just like scratch work. So I'm going to go and create like a little green bubble over here. So you've got your 208, and that could be 104 times 2, and this is 52 times 2. And 52, if you play cards, you know that that is... there's 13 cards per suit and 4 suits in the deck, so there are 52 cards in a deck of cards. But what I've got there is basically 13 times 4 times 4, and so that is the part that would come out. So we'd have 4 root 13, and then we can divide the 14 by 2 to get 7, and divide the 4 by 2 to get 2, and we end up with that. Yeah, so now you know why. And I've been working at a pretty good clip here, and this has been a 7-minute problem. Why we love these problems so much, and why you do not have a completely separate practice set for this. Now, nobody in their right mind wants to go and check this. Okay, so I do not want to take 7 plus 2 root 13 and plug that into the original equation. So this one is one that we are much, much better off just doing a graphical check. So I can't come back to this slide when we're done. So if you need to pause it, take a look at it so you have it in your notes. But here's what the graphical check looks like. So we've got the original equation there with the left and the right. And you can see that there is 1 point of intersection, and that is at negative 0.2111111 and so forth. Now, the problem is we don't know which of those answers it is. So what you see right below is our two potential answer choices. So 7 plus 2 root 13 and 7 minus 2 root 13. And what you can see is these two numbers actually match up. So this answer does not check. And this one does. And so the final answer would be 7 minus 2 root 13. Yay. Now, at this point, you might be wondering, well, wait a minute. If I can use a graph to check the solution, could I not use a graph to just find the solution? Yes, you could. In a test or quiz assessment of some sort where all you needed was the answer and you did not have to show work for it, yes, you could do that. And most teachers would. All right, let's take a look at one more example. So this is one that's got the two square roots on the same side already. And in order to solve this, we do have to get at least one. I guess it's possible if you had like a 0 over there instead of a 6, you could actually isolate both sides and then you square both sides and it would essentially make the square root go away, which would be really nice. But not going to happen. So I'm going to go ahead and isolate one of these radicals by subtracting the other one from both sides. So I'll end up here with the square root of x plus 5 is equal to 6 minus the square root of x minus 1. And then we will undo the first squaring. And that gives us the square root, square root, and you get what's inside. And then just so you can see what we're doing here, and the better you have been at multiplying, the better this goes. So we have x plus 5 is equal to 6 times 6 is going to give us 36. And then this part I'm going to do in my head-ish, sort of. Okay, so I've got 6 times yucky stuff, okay? And so it's going to be minus 6 yucky stuff. Okay, just kind of follow what I'm doing here, minus 6 yucky stuff. But then I'm going to multiply this right here, and it's going to give me minus 6 yucky stuffs again. So the two purple ones are both minus 6 yucky stuff, which means that I have minus 12 yucky stuff. And in this case, the yucky stuff is the square root of x minus 1. And then last but not least, we are going to take negative yucky stuff times negative yucky stuff, and that's going to give us positive. And when we multiply a square root by itself, we get what's inside. So it's going to be positive x minus 1. Lovely. Let's do a little bit of cleaning up on that right-hand side. So 36 minus 1 is 35, and I'm just going to bring that x around to the front. And let's go ahead and subtract 35 from both sides. And we'll subtract the x. This is kind of good news for us here because x minus x is 0, leaving me with negative 30 is equal to negative 12 times the square root of x minus 1. So that comes out nice because now when I square the left-hand side, I no longer have an x over there. Now, what I don't like about this is the size of the numbers. But what I notice is that 30 and 12 both have a common factor of 6. And so what I'm going to do is actually divide both sides by negative 6 because then I can deal with that negative at the same time. So negative 30 divided by negative 6 is positive 5, and negative 12 divided by negative 6 is positive 2, and that looks much nicer. Much, much nicer. So let's go ahead and square both sides. 5 squared is 25. And then if you recall what I did the last time, you're going to square the 2, and then you're going to square the square root, which is going to give us what's inside. And this mercifully is a simple linear equation. So distributing the 4, and then we will add 4 to both sides. So we'll get 29 is equal to 4x. Divide both sides by 4, and I get x is equal to 29/4. And this time I only got one answer out of it. So just the one answer. We want to make sure that we check it, but as you probably are not, I am not really excited about plugging in a 29/4. So let's hop on over to the graph of that one. And what I see is here's the left side and here's the right side. There is just one point of intersection, and it intersects at 7.25. So you might want to do like a quick check and say 29/4. Is that the same thing? Why, yes, 7 1/4. So x is equal to 29/4 does check. It is our only answer. So that was about 25 minutes worth of lesson. Not too bad about average. And normally I would cut out now and send you over to a practice set, but there's actually only 2 practice problems. So go ahead, pause the video and do each of these practice problems. All right, let's see how it goes. So this one, we were asked to do an algebraic check on it. We'll start by squaring the square root. To get rid of it, if I square a square root, I get what's inside. And recall that is going to be a binomial squared. And that is x squared minus 8x plus 16. So we have a quadratic. Let's go ahead and get it set equal to 0. So minus 3x and plus 2 plus 2. So we get 0 is equal to x squared minus 11x plus 18. Now, I can factor that because I can recognize fairly quickly that -9 times -2 is going to give me positive 18, and -9 plus -2 is going to give me -11. If you are uncomfortable with that, then you might want to set that up as an area model, whatever strategy you prefer. Now, we've got 2 things multiplied together, and the product is 0, which means that either the first factor is 0 or the second is equal to 0. And so x is equal to 9. Or x is equal to 2. Now, this one asked for an algebraic check. So we're going to take our original equation and plug in a 9. 3 times 9 is 27. 9 minus 4 is 5. 27 minus 2 is 25, and 5 is equal to 5. So the first one checks. Check the second one. So we'll have a 3 times 2 minus 2 is equal to 2 minus 4. So this will be 6 minus 2, that's -2. And that one does not check. So the 2 does not check, but the 9 does. And that is our algebraic check. And you can check them whichever way is faster for you to check. So I'm obviously doing quite a bit of writing, but in reality, unless your teacher is calling for a specific check, you can actually check it in your head. So if you're able to take the number and plug it in and carry out your order of operations to see how that's going to come out, you don't have to do that out. All right. Last problem. So this is like the last one that I did, where you have the 2 radicals on the same side and you cannot solve it that way. Maybe you could, but it would be an extraordinarily unwise choice. So I'm going to add the square root of x minus 2 to both sides. There is more than one way to do this, so it is possible that you might have done it differently, and that is also fine. As long as you land on in the right spot. So now we are going to square both sides. On the left, we'll get 4x plus 1. And then if it helps you to see what we're about to do, you can do it out, or you can do it in your head. If you've squared a lot of binomials, you'll get really, really good at it. 4x plus 1, and then we have 3 times 3 is 9. And then if you want to listen to my reasoning here, I'm going to have 3 of the yucky stuff, and then when I do that multiplication, I'm going to have 3 more of the yucky stuff, and 3 plus 3 is 6. What do I have 6 of? That yucky stuff. And then last but not least, we're going to take the square root and multiply it by itself, which is going to give us whatever was inside. Taking a quick moment and doing 9 minus 2 to get 7 plus x. I'll just move that around to the other side. And now we are going to subtract 7 from both sides and subtract x from both sides. So we're going to have 3x minus 6 is equal to 6 square root of x minus 2. And I'm going to do something similar to what I did before. I recognize that there is a common factor of 3 in that. 3 divided by 3 is 1, 6 divided by 3 is 2, and same here, 2, and that gives me something much nicer. Could you square it with the bigger numbers? Yes, absolutely. It would not be wrong to do so. Now we're going to square both sides, and that brings us to x minus 2 times x minus 2, and this will be 4 times x minus 2 because I'm squaring the 2 and I'm also squaring the square root. This will be x squared minus 4x plus 4. And over here we'll have 4x minus 8. And once again, we have landed at a quadratic. So we'll set it equal to 0, subtracting 4x from both sides and adding 8 to both sides, getting x squared minus 8x plus 12 is equal to 0. And this you might recognize as x minus 2 and x minus 6. Leaving us with x minus 2 equals 0. Add 2 to both sides, so we get x is equal to 2. And, I should have x minus 6 equals 0. Then we add the 6 to both sides. There we go. And x is equal to 6. And this one, you were told to do a graphical check. Could you do an algebraic check? Yes, absolutely. But we don't need to practice it more than once. So I have 2 potential answers dumping out from this considerable amount of algebra work. And when I go to check out the graph, I actually see that both of them work. So I've got the left side over there and the right, and I can see that I actually have 2 points of intersection. So a lot of times people will ask, or students will ask, well, is it true that if I get 2 answers, one of them will always check? No, like sometimes they could both check. So there you go. So in this case, both the 2 and the 6 check. And you could do that algebraically as well, just to see what would happen. All right, so that is the entire lesson. Please don't forget to like and subscribe if you found this lesson helpful. Again, that's really easy to do. Drop a comment or a question, and please check out the many other lessons and playlists that we have on the channel. And as I said before, this particular kind of equation, if this felt like an overwhelming 33 minutes to you, they are a thing. They can turn up. I wanted to make sure I included them in the playlist for students that need them, but they are not a common kind of equation. They don't model a lot of things, so you are unlikely to see them in word problems or application problems, and you don't see them in a lot of future math classes as well. So you can take a little bit of consolation in that. Please reach out if you've got questions, and I hope to see you in a future video.